Hello, hello everyone. Good evening. So here we shall solve some more KCET previous year questions on the chapter waves. So any doubts if you have in any steps, then please write that in the comments section. Um, we shall obviously clarify them in the subsequent videos. Also, in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that sound waves in air are always longitudinal because since why air does not have a modulus of uh, rigidity. Since why, if transverse wave has to travel through any medium, the medium should have modulus of rigidity. So the rule is that transverse wave, for transverse wave to waves to travel through a medium, to a medium, the medium should have the medium should have modulus of rigidity, which is also called as the shearing modulus, which is called the shearing modulus also. So, since air does not have a modulus of rigidity, so transverse waves can't travel through air. So only longitudinal waves like sound wave can travel through air. So here option 4 is the correct answer. Then here it has been told that the the loudness and pitch of a sound note depends on. So we know that loudness of a sound depends on intensity. Loudness of a sound depends on intensity and the pitch depends on frequency. The pitch depends on frequency. So option 1 is the correct answer. Then it is told in Milde's experiment in the transverse mode, the frequency of the tuning fork and the frequency of the waves in the string are in the ratio. So the frequency of the tuning fork should be same as the frequency of the waves of the string in the Milde's experiment. So the frequency of the tuning fork and the frequency of the wave should be same. It means the ratio should be 1:1. So option 1 is the correct answer. Then here it is told the difference in between the apparent frequency of a source of sound as perceived by the observer during its approach and recession um, is 2% of the frequency of the source. So as we know that which is called the Doppler effect in sound waves, the apparent frequency equals to V plus minus V naught by V plus or minus Vs into new actual. Okay. So it means the apparent frequency will be equal to V by, so here the observe, so here V is the speed of the sound and V naught is the speed of the observer, and V is the speed of sound and V is the speed of the source. Okay. So here the observer is at rest only. So the speed of the observer will be 0. So the speed of the source we have to find. So it will be V by V plus Vs by new actual if the source is moving away from the observer, and the apparent frequency will be equal to V by V minus Vs into new actual if the source is moving towards the observer. So the observer is stationary here, stationary observer. And new actual, it means we are saying the actual frequency. And the new apparent, it means the apparent frequency. So now here it has been told that the speed of sound in air is 300 meter per second. So then we have to find the speed of the source, means Vs we have to find. Here it is told the difference in between apparent frequency source of sound as perceived by the observer during its approximation is 2% of the frequency of the source. Okay. So it means that the apparent frequency minus the actual frequency, that is equal to 2% of the actual frequency. It means that the apparent frequency is 102%, 102% of the actual frequency. It means that it is 1.02 times the actual frequency. So therefore we can say that 1.02 into new actual, that is equal to 300 by 300 plus Vs into new actual. So new actual and new actual will cancel out. And then we will have, that is 1.02 into 300 plus Vs, 300 plus Vs, that will be equal to 300. 300 plus Vs, that will be equal to 300 by 1.02. 300 by 1.02 minus 300. When it is moving towards the source, then we should write v minus vs actually. So this will be v minus vs. So it means that vs will be equal to 300 minus this. Okay. So vs will be equal to 300 into 1 minus 1.02. So it will be 300 into 0.02 by 1.02, which is approximately 6, slightly less than, okay. So it is approximately 6 meter per second. So it means that option 1 is the correct answer. Then here it is told a particle on the trough of a wave at any instant will come to the mean position after a time. So here we have a wave. So these points are called as crest. This point is called the trough. So from here to here, it requires the the time period of the wave from the mean position to the mean position is called as the time period of the wave, or we can take from crest to crest, which will be also the time period of the wave. So here it has been told that how much um, time it will take for the particle to go from the trough till the mean position. So it will be 1/4 of the time period. So t by 4. So option 2 is the correct answer. Then here it is told a disc of a siren containing 60 holes. So there is a, a disc which has got 60 holes like this, and it rotates with a constant speed omega, which is 360 revolutions per minute, which is also called RPM. Then the emitted sound is unison with a tuning fork of frequency. So here, so omega, we can also say it is 360 revolutions per minute. It means 360 revolutions by 60 second. So it means that it will be 6 revolutions per second, or I can tell it is 60 hertz. No, 6 hertz. 6 hertz is the um, frequency of revolution. But here, the sound which will be emitted means, here the rule is that each hole will emit one wave. So 60 holes will emit 60 waves. So the frequency of the sound which will be emitted, that will be equal to the frequency of the revolution of the disk times the number of holes. So it will be 60 into 6 hertz. So that will be 360 hertz. So it means option 2 is the correct answer. Then here it is told if two waves of same frequency and same amplitude, respectively on superposition, produces a resultant disturbance of the same amplitude, the waves differ in phase by. So here we have one wave, which is suppose um, x1. No, suppose we tell y1, which is a sine omega t minus kx plus phi 1, and y2 we can say a sine omega t minus kx plus phi 2. So here the phase difference we have to find. They have same frequency and same. So then We know that the resultant amplitude will be equal to square root of a1 square plus a2 square plus 2 a1 a2 cos delta phi, where this delta phi is called the phase difference in between the two waves. Phase difference in between the two waves. And a1 and a2 are the amplitudes of those two waves. Here it is told that a1 and a2 are same. They have the same amplitude, let's say a. So the resultant amplitude will come a1 a square plus 2a square cos delta phi. So therefore this we can write, this will be a square I can take as common, so this will be root. So 2a square I can take as common, so it will be root 2a times 1 plus cos delta phi. And it has been told that the resultant amplitude also should be equal to a. So then we can say that a and a will get cancelled. So then we can say root over 1 plus cos delta phi, that is equal to 1 by root 2. Therefore, 1 plus cos delta phi, that is equal to half. That means cos delta phi, that is equal to minus half. So it means delta phi should be equal to 2 pi by 3. Since we know that cos 120 degree, that is equal to minus half. So therefore, option 2 is the correct answer. So the waves will differ in phase by an angle 2 pi by 3. Here it has been told a man standing in between two cliffs claps his hands and starts hearing a series of echoes at an interval of 1 second. If the speed of sound in air 340 meter is 340 meter per second, the distance in between the cliffs is the distance in between the cliffs is. So here we have two cliffs and the man is standing in between the two cliffs. So the if the distance in between the two cliffs is suppose x, so then when he creates the sound of, since he is clapping his hands, and he will hear the echo, means the reflected sound he will hear after a time interval of 1 second. So in 1 second, the sound will travel a total distance of x by 2 into 2. Since it will go to that cliff a length x by 2, and it will again return back the same length, which is x by 2. So therefore we can say if the speed of the sound is suppose v, so then v into t, that will be equal to x by 2 into 2. So then it means that x will be equal to v into t. So the speed of the sound has been told, that is 340 meter per second, and the time interval is 1 second. So it means x is 340 meters. It means the required distance in between the two cliffs, the distance in between the two cliffs will be equal to 340 meters. So option 1 is the correct answer. Then here it is told the ratio of the velocity of sound in hydrogen to the velocity of sound in oxygen at STP is. The velocity of sound in hydrogen and oxygen. So we know that the velocity of sound in any gas, that is equal to root over gamma RT by m, where m is the molar mass of the gas and gamma is the ratio of the specific heats, and r is the ideal gas constant, and T is the absolute temperature of that gas. So the velocity of sound in hydrogen that will is to velocity of so velocity of sound in hydrogen divided by velocity of sound in oxygen, that will be equal to, and at STP means where the pressure is 1 atmosphere and the temperature is 0 degree Celsius or 273 Kelvin. So STP, the full form of STP is standard temperature and pressure. So the velocity of sound in hydrogen that will be a root over gamma RT, gamma RT by molar mass of hydrogen by root over gamma RT by molar mass of oxygen. So here the values of gamma will be same, since y gamma is equal to 1 plus 2 by f, where f is the number of degrees of freedom. Now hydrogen and oxygen both are diatomic gases only. Hydrogen and oxygen are both diatomic gases. So for them, for both of them, the degrees of freedom will be 5. So it is 1 plus 2 by f. Okay. So it will be 1 plus 2 by 5 means 7 by 5. Or I can say 1.4. So this gamma RT will cancel. So it will come root over the molar mass of oxygen by molar mass of hydrogen. So it will come, so that will come square root of molar mass of oxygen is 16 gram, molar mass of hydrogen, uh, no, molar mass of oxygen is 16 into 2, that is 32 gram, and molar mass of hydrogen is 1 into 2, that is 2 grams. Okay. So therefore it is 4 by 1. Therefore the ratio is 4:1. So option 3 is the correct answer. In an experiment with sonometer, in an experiment with sonometer, a tuning fork of frequency 256 Hz, let's call it as new one, it resonates with a length of 25 centimeter, and another tuning fork having frequency, let's suppose new 2, which you have to find, resonance resonates with a length L2 of 16 centimeter. If the tension of the string remaining constant, the frequency of the second tuning fork is. So as we know, the frequency of the sonometer where the frequency of the sonometer where that is given as sonometer where that is given as 1 by 2L into root over T by mu, where mu is the mass per unit length of the wear, and L is the length of the wear, and T is the tension of the wear. So if this T and mu are remaining constant, then therefore we can say the frequency of this sonometer wear is inversely proportional to the length of the wear. So therefore we can say that nu into L, that will be constant. So therefore I can tell nu1 L1 that is equal to nu2 L2. So from here we can find out how much is nu2. So nu2 will be equal to nu1 into L1 by L2. So it means nu2, which we have to find, that is equal to nu1, that is 256 Hz, into L1, which is 25 centimeter divided by 16 centimeters. So we know that 16 is a 256, so 16 into 25, so 25 4 is 100, so it will be 400 Hz. So option 2 is the correct answer. Then here it is told the apparent frequency of a note is 200 Hz. The apparent frequency of a note is 200 Hz when when a listener is moving with a velocity of 40 meter per second towards a stationary source. So it means here it is told the velocity of the observer is 40 meter per second, and the and the source is a stationary source. So it means the velocity of the source is 0. Now, therefore, we can tell the apparent frequency. Okay. So apparent frequency which will be V plus minus V naught by V into nu actual, or the frequency of the source. Nu actual means I'm saying the actual frequency of the source. Actual frequency of the source. And nu apparent is the apparent frequency. So if the observer is moving towards the source, it means the apparent frequency should increase. So then it will be V plus V naught by V by nu actual. And so here, if the observer moves towards the source, if observer moves towards the source, and the apparent frequency will be V minus V naught by V into nu actual, if the observer moves away from the source. So then here in the first case, it is told that the apparent frequency is 200 hertz. And here we have to find the velocity of the sound, means V has been asked. V we have to find. So here it is V plus V naught, which is 40 by V into nu actual. Let's say the actual frequency is nu, suppose. And in the second case, it has been told the apparent frequency is 160 hertz when he moves away from the source. So it will be V minus V naught by V into nu. So then we have to find out V. And V naught is the same. He moves away from the source with the same speed. So it will be 40 again. So therefore, if we take the ratio, then we can say 200 by 160, that will be equal to V plus V naught, means V plus 40 by V minus 40. Since why this nu and V will get cancelled here if we take the ratio. So then from here we can see this will be cancelled. This two will cancel. 4 4 16, 4 5 is 20. So 5 into V minus 40, that is equal to 4 into V plus 40. So this will be equal to 5. So 5V minus 200, that is equal to 4V plus 160. That means V will be equal to 360 meter per second. So the velocity of the sound is 360 meter per second. So option 3 is the correct answer. Then here it is told to propagate both longitudinal and transverse waves, a material must have. So propagate longitudinal waves, to propagate longitudinal waves, the material should have bulk modulus. Bulk modulus it should have. And if it has to propagate transverse waves through it, if it has to propagate transverse waves through it, then the material should have shear modulus. Shear modulus, or I can tell modulus of ri- rigidity. Modulus of rigidity it should have. Rigidity. So it means to propagate both longitudinal and transverse waves, it should have bulk modulus also and shear modulus also. So option A is the correct answer. Then here it has been told that the speed of sound in an ideal gas at a given temperature T is V. The speed of sound in any ideal gas that is equal to root over gamma RT by M. where m is the molar mass of the gas and r is the ideal gas constant. Gamma is the ratio of the specific heats, which is equal to 1 plus 2 by f, 1 plus 2 by f, and f is the number of degrees of freedom, number of degrees of freedom of the ideal gas. And if it is a monoatomic gas, then the degrees of freedom is 3. And if the gas is a diatomic gas, then the number of degrees of freedom is 5. So gamma is called the ratio of the two specific heats, which is Cp by Cv. And m is the molar mass of the gas. And the root means square speed, the RMS speed of the gas molecules at the same absolute temperature T, that is given as root over 3 RT by m, 3 RT by m. So now, therefore, the ratio of so the velocity of the ideal gas at the velocity of sound, the speed of sound in the ideal gas at the temperature T is given as V. So the ratio of V and V RMS, that will be equal to root over gamma by 3, since RT by M will get cancelled. So now it has been told that the ratio of V and VRMS for helium and oxygen gases are X and X dash respectively. Then X by X dash is equal to how much? So now the value of the degrees of freedom for helium, since we know that helium is a monoatomic gas, so that will be 3. So the value of gamma for helium, that will be equal to root means 1 plus 2 by 3, that is equal to 5 by 3. Similarly, the degrees of freedom for oxygen, that will be equal to 5, since why oxygen, as we know, it is a diatomic gas. So degrees of freedom will be 5. So the value of gamma for oxygen gas, that will be equal to 1 plus 2 by 5, that will be equal to 7 by 5. So now it has been told the value of the ratio of V by VRMS for helium. The ratio of V by VRMS for helium, that is X. So that will be equal to square root of gamma of helium by 3. Gamma of helium by 3. So that will be equal to root over 5 by 9. It's 5 by 3 by 3. Similarly, the ratio of V and VRMS for oxygen, that is equal to X dash, it has been told. So that is equal to root over gamma of oxygen divided by 3. So now root over gamma of oxygen is 7 by 5. So 7 by 5 by 3. So that is 7 by 15. So now therefore we have to find x by x dash. So x by x dash, that will be equal to root over 5 by 9 divided by root over 7 by 15. So that will be equal to square root of 5 into 15 divided by 9 into 7. So here it will cancel out with 3. 3 3s are 9, 3 5s are 15. So this will be equal to root over 25 by 21. So 25 by 21. So I can say it is 5 by root 21. So it means option D is the correct answer. So hope all of you have understood the solutions of these questions based on the previous year KCET exam on the chapter waves. Still any doubts if you have, then write that in the comments section. Also, please install our Sapience Education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you, everyone. Bye.